Do they sound any different? You can hear it okay? Good. Okay, so this is an example of a linear equation. This is an example of a quadratic equation. You can see they're very similar except what? What's the difference?
They don't be like out of order.
The order is different? Mm-hmm.
In the wall.
Mm-hmm.
There's like no
So the order is different, but the order, remember we can always change the order in these things, so I could write this one as y equals negative 3x squared plus 4. That would be okay. The biggest difference here is a square and an exponent of 1, right? So the degree. Remember we found the degree of expressions. The degree of these expressions are the sum of the, well, we're only talking about the degree of our x term. So the degree of the x term is 2. Degree of the x term here is 1. So these have a degree of 1, a degree of 2, right? Linear equation, this is y equals 3x plus 4, 3x squared plus y equals 4. I mean, they're not parallel things. They're not equal in any way, right? They just look similar. So I wanted you to see the difference in just how they look. This one, if it's a quadratic equation, one of the variables is always going to have an exponent of 2. If it's a linear equation, there cannot be an exponent other than 1 on the variable. Does that make sense, Jacob? Does that make sense, Armani? Okay. If we graph a linear equation, what does it look like when we graph a linear equation? Anybody remember? Looks like a what? Linear. Think of the word linear. What's the root word in the word linear? L-I-N-E-A-R. Line. That's right. When we graph a linear equation, it's a line. It could be at an angle either way. It could be straight. It could be vertical, rather. They're always straight. It could be vertical or horizontal, but it's always a line. A quadratic equation is not a line. The graph of a quadratic equation is a parabola. And this is what a parabola looks like. So I need you to draw that. It's like a U that opens up or opens down. It cannot open left or right. If it's a U that opens sideways, it's not a parabola. Right? It will not be the graph of a quadratic equation. So our unit is us solving quadratic equations using factoring. So we're going to be working with equations that have an exponent of 2 on one of their variables. Y'all caught up with me?
Yes.
All right. So, go ahead and sketch that one. There's a coordinate plane. It doesn't have to be great. But you just give yourself an x and a y axis. Yeah, so this is going to be a quadratic equation. This is a parabola. So this is the graph of a quadratic equation. And looking at this parabola, I know what the solution to this parabola is, to this quadratic equation. I know what the solution to this quadratic equation is based on the graph. So one of the ways you can find the solution of a quadratic equation, if they give you the graph, you can pick it out from there. Now that's if you can read the ordered pair, or recognize what the ordered pair is. So here, this is the x-axis, this is the y-axis. So the solution to this quadratic equation is the point where the parabola crosses the x-axis. Look, it's so little. Oh, that's so big. write this here? Alright, so, here we go. This parabola shows us that there are two solutions to this quadratic equation. This is a parabola, opening down, it crosses the x-axis at these 2 points. I know the solution to this quadratic equation is 1 and 5. Now, how do I know that? Well, this ordered pair is 5, 1. This ordered pair is 1, 1. The solution to a quadratic equation is always equal to the x-coordinate of the point where the parabola crosses the x-axis. Right? Not the y-coordinate. The y-coordinate is not part of the solution, strangely. Oh, that's not 1, 1. What is it? 1, 0. Senior moment. So remember that an x-intercept term always has a y-coordinate of 0. In a few minutes, we're going to talk about factoring, and we're going to be actually replacing the y or setting it equal to 0, and this is why. Because the solution to a quadratic equation is always the point, or the ordered pair, where the y is 0, and the x is the solution. Let's get another one. Gave away the secret. Let's go ahead and sketch this one. Doesn't have to be great, just a rough sketch. X and y. This is a known solution. The solution to a quadratic equation are the x-coordinates of the point where the parabola crosses the x-axis. This parabola does not cross the x-axis. That's why there's no solution. We can graph the equation, but we can't solve it. They call the solutions zeros, roots, or solutions. But if it doesn't cross the x-axis, there is no solution. Let's go ahead and sketch this one. So, get your coordinate planes, the x and y axis, and we're going to draw this parabola opening up, and it only touches here. Now, you can't really tell by my drawing, so it is only intersecting the x-axis at this one point. So this is the very bottom point on the parabola. So that means that there's only one solution. That solution is the x-coordinate of the point where that parabola crosses or intersects the x-axis. This is called set notation. We can give the answer to a quadratic equation as x equals 3 or set notation, and we are going to move towards giving our answers with these braces around it. So x equals 3, because the parabola intersects the x-axis. The parabola is the graph of a quadratic equation, and so the solution is x equals 3. So basically what we want to know is what is x when y is 0. That is the solution to a quadratic equation. Alright, so we're going to put this in our notes next. The solution of a quadratic equation, yes?
What did the second one say? It said no solution, they do not cross.
Doesn't cross the x-axis. The solution of a quadratic equation is the x-coordinate There is no solution. So we can have two solutions, one solution, or no solution. Those are our possible solutions. Does that make sense? Based on what we've looked at so far? All right, so this was just kind of like background. We are going to be graphing, solving quadratic equations later by graphing. So I just wanted to give you a background or a little bit of fundamental knowledge on what a quadratic equation is and what the graph of it looks like. But for our purposes for today, we're really going to be finding these solutions without any graphing. You're not going to have to graph. It's going to have nothing to do with the graph right now. But the base knowledge for what does the solution of a quadratic equation mean? It means the x-coordinate is the point where that graph crosses the x-axis. So that's what we're going to be finding, even though we're not going to be using any graphing for the rest of this section. Well, for today, anyway. Sydney, you caught up with me? So now we're going to start looking at how do we actually factor and solve. So how are we going to learn, how are we going to discover, figure out what the x-coordinate is, and what is it going to look like if we don't. So for today, we're not going to have any no solutions or anything. We might have one solution, we might have two solutions, but we're not going to have any no solutions today. Are you guys caught up with me?
Yeah.
All right, a few more seconds, and then I'll come back at the end if you still need help. We should get, need a copy and stuff. We should have time at the end. All right, I'll come back if you need me to. All right. So if an equation is factored, we're going to solve it by setting each factor equal to 0 and then solving. So if the equation is factored, you set each factor equal to 0, then solve. We're solving equations using factoring today. So the directions are going to say solve by factoring, and we're going to have an example. Some of the problems are going to look like this, right? X minus 1 times x minus 5 equals 0. These are factors. We have to recognize that these are factors. Does that make sense to everyone that these are factors?
Yes.
Okay. So it says, if it's factored, and it is, set each factor equal to 0. That means this factor, x minus 1, equals 0. That means this factor, x minus 5, equals 0. This is called setting the factor equal to 0. Does that make sense? Now we're going to solve. So we add 1 to this side, and 1 to this side, so now we know that x is 1. We add 5 to this side, and 5 to this side, so now we know x is 5. So the solution to this quadratic equation, and it doesn't look like a quadratic equation, does it?
No.
Well, x times x equals what? X times x equals what? X squared, right? And x squared would make it a quadratic equation. So we're factoring, it's been factored for us. I'd like to write your answer in what we call set notation, so that's little graphics. My board is being wonky. This is the set of solutions for this equation. If you plug 1 in here, it's going to make that 0. 0 times this factor equals 0. It also makes the equation a true statement. Let's see this one. If we multiply these together, will they be a quadratic equation? So x times x is what? X squared, because that's what a quadratic equation is, right? So one factor is x, the other factor is x plus 5. Does that make sense to you, Tyrese? If this is saying this times this equals 0. So one factor We're setting that equal to 0. The other factor, we're setting that equal to 0, right? And now we solve. Well, this is already solved. We don't have to do anything here, but this one is not. So we're going to give our answer in set notation. One of the answers, once we set it equal to, that was already the answer given. The other one is -5. Probably we would put the negative first, but the order doesn't technically matter in these braces. Typically we would put the smaller one first, but it doesn't, it's not right or wrong if you don't. Does that make sense, David? So that's your first group of problems. Oh, no, it's not. It's the first 4 problems. All right, you with me? Okay. If it is not factored, this is what we're going to do. So these are our steps. You guys like steps. If it's not factored, set the equation equal to 0. Factor decides it's not 0. Then we're going to set each factor to 0, and then we're going to solve. So we've got 2 steps before what we just did. And we can go ahead and write this equation, and we'll do that one together. Alright, so when we say factor, we're only talking about factoring inside that's not equal to 0. So this says set the equation equal to 0, but this is already equal to 0. So we are saying that this equation is set equal to 0. That means one side is 0, everything else is on the other side. Does that make sense to mind? Okay. The next thing says to factor. We've got a binomial here, we've been factoring. And it's got a plus. So we know we can't factor this into 2 binomials, but is there a greatest common factor we can pull out of both?
Yeah.
What's the greatest common factor, Jacob? Right, x. So we can factor this to x times x plus 3 equals 0. These are equivalent equations. Does that make sense to Taj?
Huh?
Are you awake?
No.
Are you writing what I'm writing?
Huh?
Are you writing what I'm writing?
Yeah.
Does this make sense?
Yeah.
Okay. So it was already set equal to 0. We just factored it. Now we're going to do what we did in the last page, set each factor equal to 0. So x is equal to 0, that's one of the factors, and then x plus 3.
And then we put -3 on.
Right. We're solving this one. And so now we know that one of the solutions is 0, and one is -3. So we're going to write it in set notation, -3, 0. What do you think?
I like this.
All right. Stacy, caught up with me? All right, let's go to the next one. So the equation, one side of the equation must be 0. So the equation must be equal to 0 before you can factor it. So now we're going to do one that's not equal to 0, and I'll show you what that means. So this is the next thing you're going to write. Quadratic equation, there's n squared here, but it's not equal to 0. you think we could do to get it equal to 0?
Divide.
If I divide 5 by 5, do I get 0?
Wait, no, Solve.
If I multiply 5 times 5, do I get 0?
No.
The only number you can multiply another number by to get 0 is 0, right? So we're not going to multiply.
Yeah.
Subtract. Yeah, what are we going to subtract? What makes the most sense? Do we want to subtract n squared, 7n, and 15?
No.
I could just subtract the what, Steven? The 5, yeah. If we just subtract this 5 from both sides, well, you can do whatever you want to an equation, as long as you do it to both sides, right? So now, 5 minus 5 equals what? 0. So now here we're going to go through, we didn't do anything to the n squared, nothing to the 7n, and now we get 15 minus 5. Remember, we're subtracting from whatever like term it is. So this is a constant, so we subtract it from the constant on the other side. So now we have an equation, n squared plus 7n minus 10 equals 0. Jacob? It would be something. Thank goodness, because I was just thinking that doesn't work to factor. Yep, get rid of the plus, my bad. Thank you. Thank you, Jacob. 15 minus 5 is not negative 10, it's positive 10. All right, so now, you don't want to go back because you got to write in front of you, but here, it was set equal to 0 and then factor. So now we're going to factor, and this is one of those where a is 1, the coefficient here is 1. So we're going to do binomial times binomial. It's going to be equal to 0. We're going to use our x. What's going to go here for these kind of problems? Do you remember? Not 0. 10. What's going to go here? 7, the middle one, right? Right now we're only looking at this. We've already changed the form of our equation, so this is the one we're looking at. So we had these two factors that when you multiply them together you get 10, and when you add them together you get 7. 5 and 2. And it's positive and positive, right? Positive 5 plus positive 2 gives me positive 10. Positive 5 plus positive 2 gives me positive 7. So now, what goes in my factors here? What goes in the first spot in both parentheses? N, not n squared, but n, right? What goes in this first one? Plus 5. What goes here?
Plus 2.
Plus 2, right? N times n is n squared. If we multiply this together, we get this. So now it's factors. What do we do now?
Solve. Wait.
Now we set each factor equal to 0. We have two factors. N plus 5 is a factor, we set it equal to 0. N plus 2 is a factor, we set it equal to 0. Now we solve. Minus 5 minus 5. So n equals negative 5 minus 2 minus 2. N equals negative 2, and we're going to give it our answer in set notation. Does that make sense, Caleb Berry?
Yes, ma'am.
Does that make sense, Tony? You guys caught up with me? Need a little bit more time? Ooh. Is that a quadratic equation?
Yes.
How do you know?
It's a lot of things. A lot of numbers.
So there could be a lot of numbers in a linear equation too. What do you think? Look at your T table in the very front. What was the difference? Oh, Todd should write his.
The walk. Wait, yeah. It was not square.
Right, this one's squared, right? The quadratic is square, has a squared variable. So linear doesn't. So now when this is a quadratic, is the equation set equal to 0? You don't see equal to 0, right? We need one side equal to 0. We always want that a squared squared term to be positive 2 or factoring is always easier. So if this is here, we're going to move all of this over here. So how are we going to move the 3 to the other side? What will we do?
Minus 3.
Minus 3. So let's do that. Minus 3 and minus 3. So 15a squared minus 3a. I can't take the 3 from these two because they're not like terms, so it's just minus 3. Now that's equal, that goes to 0, and that's equal to negative 7a. Is it equal to 0 yet? You know it's not equal to 0 because it doesn't say equal to 0 yet. So how can we get it equal to 0? What can we do now? Good. It is plus what?
Plus the 7.
Plus the 7a, right?
Yes, 7, 8.
Very good. So we're going to do that to both sides. So plus 7a. And over here, we're not going to add 7a to the constant.
We're going to add 1.
Yes, we're going to add it to the like term, that same variable, same exponent. So we're going to add it to 7a here.
We dropped it off.
Negative 3 plus positive 7 is positive 4a. We didn't do anything to that, so we bring it down. That's 0. Now we have an equation that's equal to 0. So once we have an equation that's equal to 0, now we factor. Now this has got an a greater than 1, so this is going to be one of those we had to factor by grouping, or factor by splitting the middle term, right? There's not 4 terms, so we're going to make 4 terms. So now we're doing the stuff that we did before. So if you did not know how to do the factoring and you thought you were home free, you are not, right? You still need to use the factoring, so you still need to try to work towards learning how to factor. So we're going to do what is A, what is B, and what is C. Tyrese, what's A, B, and C? There's no 5 in there at all. There's 15, there's a 4, and there's a negative 3, buddy.
4 negative 3. Bro, it's really big. 15 is 8, and B is 4.
All right, so, Tyrese, we learned earlier, and we've talked about this a couple of times, A is a number being multiplied by the x squared term. B is a number being multiplied by the x, and C is the constant. Okay? So 15, 4, and negative 3. So now we need to multiply A times C, actually. So AC equals 15 times negative 3, which is negative 45, and that goes in the top of our x. So now we need 2 factors of negative 45, and when you add them together, you get a positive 4a, so positive 4. We're not factoring it, we're splitting the middle term now. Caleb?
9 and negative 5.
Nice. 9 and negative 5 is exactly right. Plus 9, negative, if you multiply those, you get negative 45. If you add them, then you get 4. That is perfect. So now we are rewriting it, and we're splitting that middle term. So 4a is equal to 9a minus 5a, right? 9 minus 5 is 4a. And we're going to bring down the minus 3. Now we've written another equation that's equal to the one we had. It's just in a different form. Does that make sense, Tyrese?
Yeah.
Okay. Now we've got 4 terms. Now this is when we factor by grouping. So we split it into 2 groups. What do we do here? What do we do here? Do you remember?
You get the GCF.
Good.
Greatest common factor.
The GCF of each group. What's the greatest common factor of the first group? What's the greatest common factor of 15 and 9? 3. What's the greatest common factor of a squared and a? 1a. A, right? A times a and a. The biggest number of a's that they both have is just 1a. What is the greatest common factor of negative 5a minus 3? This one's a little bit tricky. Zanaya, do you remember? What's the greatest common factor of this one? It's a little bit tricky. It is 1 because there's not a factor, but this is a minus. So what's it going to be, positive or negative 1? Very good. If this is negative, our factor is going to be negative. So now, let me go down a little bit. We know these 4 terms factor into 2 binomials, and now we have enough information for our first binomial. What's our first binomial? Space, do you know? Okay, so it's these common factors here. Aiden, you going to tell me?
3a minus 1.
Yep.
And then we would divide the top by 3a.
The first one by 3a?
The first one by 3a.
And so what's this factor going to be? 15 divided by 3 is? 15 divided by 3 is? 5. A squared divided by a is? A. 9 divided by 3 is? And then a divided by a is 1. So 1 times 3 is just 3. So now, we do all of this. Now we finally have our factors. But we still haven't solved the equation. Now once we get past the factoring, now we set the factors equal to 0 and solve. So we've done all the hard parts though. We've done all the hard part. We've got to get back to here. Now this is one factor. We set it equal to 0. This is one factor. We set it equal to 0. And now we have to solve them. So we're going to add 1 to both sides. Now we have 3a equals 1. Now we have to divide both sides by 3. And so a equals 1/3. Yes, it can be a fraction. Here we're going to subtract 3 from both sides. 5a equals negative 3. Divide both sides by 5. And a equals negative 3/5. We're going to give our answer in set notation. Negative 3/5 and 1/3. So if this were graphed, this parabola would go through the points negative 3/5, 0, and 1/3, 0. We don't know which, right now you guys don't know how to tell which way it's going to open or anything like that, but any questions? I think we are. I think that's the last example. I was going to see, I can't remember if I said odd or even, I should have said even on your homework, but let me see.
No, there's no odd or even.
Oh, it should say even, so go ahead and mark even. I know, but on the assignment in Canvas it says even. So we're doing the even problems. So if you want, we could do an even problem or two to reduce your workload for tonight.
Yeah.
Okay. Let me get it pulled up. So you guys, which one you want to do?
Start with the first one.
You want to do 20?
20, yeah.
Okay. If you do not want to follow along with us now, you don't have to. You can just work ahead if you feel comfortable, or you can work with us. We're going to do only the even ones, so that's the right column. So everything down the right side, you don't have to do the left column tonight, only the ones on the right. Okay, so is this equation factored? It's set equal to 0 and factored. So what are we going to do?
Solve it.
We are. How are we going to solve that? Look at your notes.
Put
Go back now.
wait, go back. No, I know.
You know?
It's b equals 0, and then you drop down the other layer, the 12, but that's gonna be b plus 12, and that's gonna equal to 0, and then we're gonna put
Good.
minus 12 on both sides.
All right, so it's b, so we set each factor equal to 0 first. So this is a factor, we set it equal to 0. This is a factor, we set it equal to 0. Now we solve. This one's already solved, so number 20 is the one we're doing. This is already solved, that's going to go in our braces. Here we're going to subtract 12 from both sides. When we solve it, it means we're getting the b by itself, so now we know b equals negative 12. So the solution set for number 20 would be negative 12, 0. So these first three are set equal to 0. You don't have to get them equal to 0, right? But you do have to, and these two are both factored. This one is not factored, but it is set equal to 0. This one is not factored or set equal to 0. So how are we going to get number 26? Let's do 26. How are we going to get it to 0?
Set the equation to 0, but
Well, we have to do something to get it equal to 0, right? We want to keep this positive, so we're going to leave the 2x squared where it is. We want equal to 0 here. So how can we get this to move to the other side?
plus it, minus it.
Minus it. This is a positive, so we want it to be equal to 0. 3x minus 3x is 0, so we do that to both sides. Now we have 2x squared minus 3x equals 0. So now it's equal to 0. Now what do we do? Set it equal to 0. Then you factor it. So how are we going to factor this?
Set each factor to 0.
Well, we don't have the factors yet.
Then we gotta factor it.
Right. So 2x squared minus 3x. Not a perfect square minus a perfect square, but is there a greatest common factor?
Yes.
What's the greatest common factor?
Yes.
X is right. So x times 2x gives me 2x squared, minus x times 3 gives me 3x. So now I've got it factored. Now what do we do?
Set each factor to 0.
All right. What's the first factor?
No. Oh.
What times what equals 0? X times 2x minus 3 equals 0, right? So x is a factor, and 2x minus 3 is a factor. So how do I set my first factor equal to 0? What do I write?
X minus 2.
Nope, just this is the first factor, right? It's just x equals 0.
Oh.
What's the second factor?
X.
So this is the second factor, 2x minus 3. So this times this equals 0. So the second factor is 2x minus 3. And we set that equal to 0. Does that make sense, Anaya?
And then we will plus the 3.
This one's already done, but this one we need to add 3 to both sides. And divide by 2. And x equals 3 halves. So now, if we're given this answer in set notation, it's 0 and 3 halves. Y'all want to do one more? You see one that you want to do?
Yeah.
Which one?
Number 24 on the bottom.
Okay, the bottom 24. Got it. So the bottom 24, the first thing we're going to do is get everything moved to the other side. And I'm going to run out of room, but I'm going to rewrite it. So I'm going to subtract 10d from both sides. So now I have 6d squared plus 11d equals, that one's a 0, 35. You notice I subtracted the 10b from the d term. Now I'm going to subtract 35 from both sides. There's not a constant over here, so I'm just going to write it here. I'm out of room, so I'm going to come back up top here. So I'm going to have 60 squared plus 11d minus 35 equals 0. Good. Now we have a coefficient greater than 1 here, so this is where we're going to split our middle terms. So we need our a, our b, and our c. We're running a little low on time, so I'm going to kind of walk you through it. A is 6, b is 11, and c is negative 35. So the next thing we're doing is AC. That means a times c, or 6 times negative 35, which is negative 210. I have no idea which factors that's going to be. So now remember, we give ourselves an x. We need a product of 210. That means you multiply them together to get a negative 210. And when we add them, they're going to be a positive 11. Oh, I don't think I've got that. If I divide 210 by 10, I'm going to get 21. So 21 times negative 10 is negative 210. Does that make sense? If I add 21 and positive 10, or negative 10, I get 11. Okay? So that's what I'm going to do. Positive 21, negative 10. So now I'm going to rewrite. This is stuff from our last lesson that we just tested on. So now we have 4 terms. Now we can factor by grouping. And I am speeding through it a little bit, like I said, because we're running out of time. Greatest common factor here is going to be 3D. Greatest common factor here is going to be negative 5. So our first factor is 3D minus 5. And then we're going to divide this by 3D, this by 3D, and that's going to be 2D plus 7. And you may have to finish this on your own, but now we can set our factors equal to 0. Mm-hmm. 2D plus 7. And you're going to add, you're going to solve those two equations and put them in their braces.